Okay, so it's another day, more work, etc., etc. Now, I've spent the entire morning researching into nuclear blast and radiation to better program the effects we're putting into the game. And what I can say after doing the morning worth of research is there's so much to learn that it's going to take me a while to get this right. So expect a lot of additions and changes in the future as we move forward with the understanding of how things work. For the moment, I do have a radiation map now sort of programmed for the game. It is untested, so we're not going to actually work on it right at this moment. I haven't exactly planned out what we're going to work on for this session of development anyways. But what I would like to know really quick is some of the data I have discovered while studying radiation and kind of how I'm going to implement it into the game. Now, one big thing I've actually figured out, and in my note, I've been reading articles mainly from government sites and Wikipedia. And I might note Wikipedia is not the most trustworthy site, but it's about the only one I could find that had a really large source of information to work on. So we're going to go ahead and open up this document here. Now, I did post this on Patreon, so anybody who's on Patreon can find the link really quickly. It's also on Twitter, so you can find the link to this document and look through it. Now, right now it's only 2 pages. I expect I'm going to put a lot more notes in here. I do have a notebook that has about 6 or 7 pages worth of notes in it as well, although that's about 2 pages when it's converted to a Word document. What I have discovered is there's quite a few units used to measure with. We're probably only going to, one we're going to use is probably rad and potentially gray. But gray is a little bit confusing because, as it notes right here, it's equivalent to 100 rads. And then if you go around, you go look at something like Fallout, which uses rads as well. The highest I think I've seen in Fallout is 200, but then at the epicenter of a nuclear blast, you get like 3,000 rads. So it's going to be really hard to figure out how we're exactly going to measure this. Now, one thing I also want to note is we're not going to just be using radiation just for nuclear blasts. It is going to be used in reactors. There are going to be weapons that produce radiation. There are going to be a lot of stuff that does use radiation and various other things. For example, space travel is going to involve a lot of radiation, but it'll be different types of radiation. After all, there's alpha, beta, gamma, whatever. I haven't even come close to studying all that. I know that nuclear blasts release a lot of different types of radiation. Each one has a different effect on a person. So we're just going to do a flat out type of radiation for the entire game. And we're just going to assume this is related to nuclear stuff, which is going to be probably mostly gamma, from what I'm understanding. We are going to be using RIM a little bit. RIM is to note the risk of radiation to a person, where rad is how much radiation you have actually absorbed. So if you've absorbed 100 rads of radiation, you are actually within risk of getting radiation poisoning. Although if you play Fallout, Fallout just immediately screws you over after like I think 10. You start taking negative effects. So it's really confusing. If you've ever played Fallout or other games, do not use numbers from that game to directly reflect what we're going to be doing inside of Minecraft, because the numbers are not going to match up. I'm not going to say radiation barrel gives you 25 rads per second, because it's not going to quite match up correctly. Not including the fact that apparently having just a couple millimeters of material between you and a radiation source almost immediately drops the amount of radiation. I've got notes. Actually, I didn't write them down in here. I wrote them down in a notebook over here. But 9 centimeters of lead will drop your risk by 50%. However, turning around in let me get my notes over here. 6 centimeters of concrete will do the same job. Oh yeah, it's 1 centimeter of lead, 6 centimeters of concrete, 9 millimeters of packed earth, or 150 meters of air will all drop your risk by 50%. These are compounded, so the more layers you put between you and the radiation source, the less likely you are to get radiation. Now, considering almost every block in Minecraft is a meter, a single piece of dirt would basically make you immune to radiation, which is surprising but not surprising at the same time. So it's highly likely that a lot of the radiation sources we're going to use, as long as you put something between you and the radiation source, you'll be fine. That being said, I probably will do saturation of material, so dirt is organically based, and of course dirt in Minecraft is not packed, so it is likely you're still going to get radiation even through normal dirt, but we will have things like packed dirt, which we already plan to put in military-based accord, not as a radiation barrier. The reason for packed dirt was actually used as fortifications, because surprisingly, doing something as simple as putting packed dirt and building a trench will protect you from things like artillery and stuff really, really well. It is something that is even currently used all the way up until today. They will still build foxholes, they'll still build trenches to protect troops and various other things. That apparently will also protect you from radiation rather well. Radiation particles, of course, let me pull out paint as well for this. This is the reason why I actually started this. I was going to make a diagram for this video. I haven't got that done yet. But what I did figure out is radiation goes out in a straight line. So if you put a barrier between you, it's going to work to stop it. But not just that, is if the radiation where particles are going out here, it's there's a square something factor that you could have this huge epicenter, but as you go out further and further, it kind of shotgun effects and it gets farther spread apart. So the farther you get away from the center epicenter of the blast, the lower amount of radiation exposure you get. It's not the fact that you're getting less radiation, it's you're getting hit by less particles. You're getting hit by less matter and everything else. Another thing we're going to be probably working on with this is fallout will be a thing. Fallout, however, is going to be calculated based on the amount of debris and dust thrown in the air. So small explosions are going to throw up less dust than bigger ones. And it's also going to be based on the weather effect. So if it's raining, the amount of fallout is going to be dramatically decreased. If the wind's blowing really, really hard, the distance by which it spreads is a lot higher. If there's no wind, then the distance is going to be almost zero, so you're not going to see a huge amount of that. That's going to be the most negative effect actually out of all this, because that will spread radiation a little bit everywhere. I haven't found documents on to explain how big that is. The only thing I managed to find is a 15 megaton test that they did had a 500 kilometer downwind radiation spill. This was measured in multiple cities. It kind of makes you think how retarded they were that there are places irradiated on this earth from just peaceful nuclear tests, where they were testing in places like Nevada that are now irradiated because of it. Although it's not a lot of lethal radiation. It's really, really confusing how all this stuff is measured, and what I'm finding is that unless you're hit by a really, really large dose, you're hit by lethal amounts of radiation, usually you survive with not a lot of actual damaging effects. It's only when you've been exposed to lethal amounts of radiation for a very long period of time that you are almost guaranteed to die. Take example of Chernobyl. I know a lot of the workers there did die, but it took them several days to die. Nobody died instantaneously. So as I was noting in a previous video where we were going to talk about instantaneous death radiation, apparently that's not a thing. You don't actually die from instant radiation unless you're in the range of like 5,000 plus amounts of grays being hit with you, which by the way, gray is a measurement of radiation right here for those who weren't following along. So you have to be hit by just these absolute ridiculous amounts. Actually, I believe this document covers that. Yeah, I was reading this on trying to... Actually, I think I've shown this on here before. Yeah, here's what, notice the ranges, by the way. So 1 kiloton, which is what we dropped on, I think, Nagasaki. You're not going to even be within lethal range unless you're 0.8. This is actually using the document that shows the radiation amounts. I think it's this one. This one shows the fallout. This is the one where it's talking about how far. This was the Bikini Islands, and you're looking at like almost 300 miles away where you're starting to see fallout. That's ridiculous. It's also showing where radiation spreads usually in a cigar shape when it comes to fallout. That's wind pushing it around. Should be an effect down here somewhere. Here's nuclear shielding, by the way. I actually want to find a better article on this. I believe you can probably read some civil defense articles here. A lot of this stuff is public information. After all, people used to build bomb shelters in the 50s, so the government released a lot of documents explaining how to build proper bomb shelters. Oh, here we go. So this is where it's talking about how much radiation you can take. So for a 10 kilogram, you can get 30 grays of radiation per hour. So this will kill you. However, if you only get 1.6 gray or 1.5 grays, you're just going to get tired. It's actually apparently not even going to have a negative effect on you. 30 grays, though, being hit by you, you're immediately going to get screwed up. You're actually going to probably have to be dragged out of the epicenter if you don't get disintegrated by the thermal energy. That's one of the things why when I'm working on this new blast, I don't want to just have a TNT type explosion and then radiation, because that doesn't reflect the actual destruction of the blast. One of the biggest things, the reason why blasts are actually highly destructive is because of the blast waves, the amount of heat sent out, ionizing radiation, which will screw up electronics. This is one of the biggest parts I want to work on is the ionizing radiation, is that it will cook the actually, I think it's the thermal energy that cooks the atmosphere and makes ozone and stuff. It will prevent radar from working. It will prevent radio waves from working properly. It will actually screw up a lot of things. Now, radio waves by themselves will prevent you from launching missiles remotely. The range on this is like 500 plus kilometers. It lasts for 5 minutes. So that's like 5 minutes you can't launch anything or do anything else. That's 5 minutes your radar doesn't work, so your AA systems aren't going to function properly. This is going to be really, really important as you starting to see the nuke as not just a destructive weapon. You could airburst it and then just wipe out everybody's defensive systems. A lot of things we're going to work on. Anyways, for this video, we're probably going to get back into working on the blast again. So we've got the current blast has an instantaneous radiation, has a flash effect, and it has some destructive capability and some various other things. I'm going to go ahead and launch the game here, and we can take a look at what's going on. And then we can kind of plan out how we're going to do it. Now I'm going to do one of these videos today as I've got to go attend a graduation for a cousin of mine. And that's pretty much going to take the rest of my day. And then Sunday I'm not going to be making videos at all here because I'm going to be focused on schoolwork, trying to finish off the last 2 assignments for the week. I've got to read a lot of books I haven't still read yet. Which is ironic when you think about it. I just spent the entire morning reading about radiation and various other things when I could have been reading about the IT security and UML design. My physics professor would be laughing at me because I had opportunities to read about this stuff several years ago because I was interested in physics and I was thinking about getting into a career in physics. And one of the things you'll ever learn in physics is how radiation works, because even though we think radiation only exists in nuclear weapons and reactors, it exists everywhere. There's always a constant background radiation, and it affects everything. There's tons of different types of radiation. For example, our sun emits a lot of different types of radiation. Not all of them lethal. Some of them are actually harmless. To be honest, the heat we get from things is infrared radiation. So radiation is actually a term applied to the way particles travel. It's actually not a generic term to describe harmful particles. That would be ionizing radiation as harmful particles, because it'll mess with DNA. Speaking of which, apparently people figured out a really easy way to protect people from radiation. At least they figured it out a way we could do it. They haven't figured out how to do it to human beings yet. You can put hydrogen around people's cells in their body, and it will actually prevent ionizing radiation from destroying the DNA. But they haven't exactly figured out a way to get humans to produce this. But if they ever could, so this would be something that would be a great add-on for some of the genetic mods in Minecraft, that somebody could do this, and then you're immune to radiation for short periods of time. I know the way we're going to do radiation protection in this game, though, is primarily going to be lead plates, is how you're going to do it. Lead and graphite plates. Because graphite plates can slow down neurons, or neutrons, actually, is what I meant to say. Yeah, neurons are brain signals. It's going to be a long day. But yeah, so you use graphite, you'll be able to slow down the neutrons, and the lead will be able to slow them down even further. I got to do a lot more research on this. The stupid thing is, the more I research this, the higher likely I'm going to get a letter asking me why, or a knock on the door asking me why I'm being researching into these things. I forgot to turn my headset audio back on. So if you hear some echoing through the microphone, that's because the speakers are running right now. So here's some of our previous blast where we mainly got cobblestone. Now I haven't really worked on this, but you know what? This actually might be a good thing to work on today. It's just working on some different variety of cracked stone and different ore types we can play around with. Because that'll give us, not only will it give us more stuff to work with when it comes to the blast code, but it actually will give us more stuff to work with in other content. So you could actually build a thermal drill here later that would intentionally crack stone and turn it into gravel, and then you could turn around and use that old effect. Actually, I could show this effect to you real quick, since most people probably don't know what I'm talking about offhand. There's a thing you can do in Minecraft where you can break blocks really quickly that are fall based. Although there has been talk about making mods to correct for this, and I have actually thought about making a couple myself. So when you have a solid thing like this and you break it, anything that hits something like that, it doesn't have to be a torch, it could be rails, anything that's not a full block, because the collision box of the sand block will go through the torch, it'll break the sand. So imagine if you had ore that was like that, you could just really quickly suck the ore up. And I'm pretty sure we're actually going to do stuff like that. Although we're probably going to do things like molten and solidified rock and various other stuff like that. So you'll have something that'll be like a molten ore block, and you won't be able to identify what the ore is until you break it because it'll just be so congealed and messed up. Anyways, let's go ahead and shoot a nuclear blast off to see how our code is looking right now. Oh, I'm getting a message here. So I can't be long here on doing this. This is going to probably be a short video for today. We got particle effects working, or not particle, we got debris working yesterday. I think it's what we did. I do have to spend a lot more time working on this. A couple of the notes I put into the code, I need to figure out what direction the blast was moving and attempt to throw the debris upward and in that direction. Because what we're doing is we're getting some randomization effects where it's throwing every... What is that? I think it's a slime island. Oh, it is a slime island. Oh, bye-bye slime island. Yeah, I see how the particle effects are like randomized and we're not having a good direction with them. I need to get the blast direction so they're not as randomized and we don't end up with a lot of particles just getting stuck inside of walls and stuff. Because it just kind of defeats the point of particles because we have a maximum limit of the number of particles that can actually exist at one time now in order to reduce lag. Because you notice if you're watching my frame rate in the top left, my frame rate barely ever tanks. It actually does really, really well now with the adjustments we made to the fragment system. See, it goes down to about 44, which is a good, I mean, it's a pretty good drop. Well, going down to 9 because I opened the GUI up. But it stays pretty good considering the fact that I'm recording at the same time and I'm running stuff in the background. And my computer CPU is about equivalent to slightly above an i3, slightly below an i5. I used to think this CPU was really, really good, and I started doing a lot more research, which I should have done before I bought the computer, that these AMD CPUs, even though they do floating path math better, their frequency rate is not actually what it appears to be. So I've got 4.6 gigahertz on the CPU, but that actually correlates to about 3 point something on an i3. So it's actually a pretty bad loss, although I found out a lot of servers actually run at 3.2, so it's kind of a little confusing kind of how that works out. Anyway, so we got particle effects, we got fire. I need to kind of work on the fire. I don't want to have as much fire placed around because that's one of the main reasons my FPS is dropping. And I need to make sure that these blasts are efficient. The reason they need to be efficient is because you can imagine if you're having an actual thrown out battle on a server, you could be having like 40, 50 large blasts impacting along with AA fire, machine guns, mortars, artillery, drones attacking each other, bases exploding, reactors going, machines and cables. So your FPS could be 1 even on a large computer if I don't take care of some of these FPS problems right away. Anyways, 17 minutes into the video, so let's get into coding. So we'll just work on some thermal blocks here. This will be a good thing to do today, and then I'll end this video pretty early. So let's make some crack stone. Let's figure out what happened to our heated blocks. That's one thing that should be functional, but it's not. Yeah, actually, where is our heated blocks? Because I just realized we have something that basically is crackstone. Okay, so we go in the core, and let's see what we're going on with. And let me close some of these other tabs since we're not going to be working on the radiation map today, even though I thought maybe that might be a thing we could work on. I got to just unit test that. My buddies are, yeah. Let's see. I might have disabled it by mistake. I might have been a derp there. Okay, so we got a heated stone conversion here, and yeah, we should probably just work on this here real quick and see if we can get that kind of rolling forward. The problem we're having with this, the reason why we're not seeing this actually pop up, is right now we have a cobblestone replacement for this, but what we need to do is do heated stone, and then heated stone will decay into cobblestone. So if enable heat map, load heated stone. Yeah, we'll do an else statement here. So we'll go, if the heated stone isn't enabled, we'll use cobblestone, and we can go to here. This is where I kind of need some JSON data for this stuff kind of too. Is we have this right here, which is what we want to get rid of. And let's go ahead and launch and see if that we actually get some behavioral logic out of that. I have a feeling we probably won't, because I'm not quite sure if the heated map is programmed correctly. We still haven't done the energy system, as I've noted. I don't have the heated map set up yet, because how the exothermic is actually supposed to work is it's supposed to literally dump 1 million joules of energy at a fixed point, and then the heated map is supposed to spread that energy out as quickly as possible and melt all the blocks around it. Might have noted 1 million joules of energy dropped at a point will disintegrate like every block within a certain radius. And actually, it's not 1 million joules, it's like 1 million megajoules or something. Because 1 million joules is how much it takes to just heat up like a cup of water, surprisingly. I'm never going to understand thermodynamics. I actually took a class on it at one point, and I dropped out just for this reason, because it was just the amount of math they threw at you, and then it wasn't just even the math, it was trying to mentally comprehend the fact that the numbers you were working with were in the millions when you were talking about something the size of a baseball. It just didn't work in my head, and I'm like, if you're working with numbers in the million, why haven't you come up with some kind of conversion to come up with smaller numbers to work with? That way you can do this math quicker. Because I know computers have a limit on how big of numbers they can have in them. For example, if you use an integer, it's like 2 billion, I think is somewhere where it's roughly around. So if you're trying to calculate, for example, how much energy I need to put into a lake to raise the lake by like 3 degrees, you're going to end up with numbers in the trillions. I actually probably could do the math right now by number of gallons and energy lost to soil. I might make a simulator for this later. It'd be fun just to have this little physics simulator where you can throw like hot marbles into water and then watch the water temperature raise. It'll also give me a really good way to test a lot of physics and make sure that my physics engine that I'm putting into Minecraft actually functions properly. It's been something I've actually considered a lot, because I actually want to take all the physics I'm putting in here and I want to take them to my own game here down the road, so that way if I do some thermodynamics system in my game, I can just take this entire engine I built up for Minecraft and then not even have to change anything, just bring it right over to the game and start using it. It's one of the things I've been kind of planning out, because I want to make my own Minecraft S-style game down the road, and I don't want to recode all my mods and stuff. I want to just go, okay, these are now official DLCs for the game, and at the same time, they're still unofficial mods for Minecraft. It would be kind of cool to have that. The content is literally identical and the gameplay doesn't change any. Actually, the gameplay probably would change a little bit. I would actually, because the Minecraft S game I want to make is actually going to be really extremely realistic, to the point where you can pull levers, push buttons and stuff. That's something you don't see in Minecraft. It's really, really hard to do in Minecraft as well. But inside my own game, it would not be as hard, because all I have to do is ray trace to the button and go, oh, you ray traced the button, and that's what you right clicked on. Therefore, you click the button. I probably won't make everybody do that though, because accessibility reasons, it would be really dumb to have to do things like that. We're going to have a lot of work to do with the heated system here, because I need to do cobblestone, I need to do a variety of different blocks. There's a high possibility I'll start programming tile entities for this action, because of the fact that I do need to support a wide range of blocks, and the quickest way to do that is with a tile entity. Because what happens when you hit stairs? Do you want to melt the stairs into a slab? What happens if you hit a slab? Do you want to melt it into a slab as well, or do you want to do something a little bit more complicated with it? Now you also have to do the fact you got blast physics involved in this whole thing, and do you want to... Oh shit, I shot a nuke twice. That's going to be fun. I need to work on getting these calculations to run quicker, so that way if I did fire that twice, the first one would have went off before the second one even landed. Okay, did we get some heated stone mixed in here? I can't really tell. Oh, yes, we did. Okay, so heated stone, look at that red molten stone. It's supposed to reflect a temperature system, so that way if you stepped on this stone, it would heat you up. And you can watch, there actually is a color change going on with the stone. It'll slowly work its way back to normal stone. Although I don't want it to actually turn into normal stone, I actually want it to turn into molten stone when it's done. And I want to kind of work on a much larger variety of this as well, and I definitely need to work on the textures. This should not be molten red, and then when it temperature shifts, so when it red shifts and stuff, it should go from white to orange, or if we go from white to red to orange to I don't know. I have to figure that one out. There was a collar ship that actually reflects when you go from molten to non-molten. One of the things I also want to work on with the molten stuff is actually having blocks that would try to flow down to the bottom here, but they would solidify too quickly, so you would see this molten jetty stream going down, and it would look really, really awesome. Although the downside of that is it might actually be CPU intensive, so I'm definitely going to have to add configs for this. Let's just sit here and see how long this takes to tick. It is a randomized tick system, so not actually sure how long this is going to take. I also need to implement things with this. If you pour water over it, it'll cool down much quicker. Potentially boiling the water off too. Steam is something I do need to add, so that way you'll have steam effects. I need to add if you get hit by the steam, you can get 3rd degree burns. For those who don't know what difference is between the different degrees of burns, 1st degree is like you touch something hot and it hurts. 2nd degree, your skin's going to fall out. 3rd degree, it probably completely messed you up. You're going to have scars. I would show pictures on this video of what 3rd degree burns look like, but because people are pretty sensitive to that kind of stuff, I'm not gonna. I've seen a few videos and pictures and captions and stuff, and imagine somebody's skin falling off. Yeah. Keep in mind, we actually are probably going to implement things like that in this mod. If you are squeamish, actually, you know what I'm going to do? If it's the first time installing the mod, there's going to be a prompt that's going to come up in game and go, okay, are you squeamish and do you not want to see this? And it'll actually give you a list of what's going to be seen, and you can sit there and check mark each one off. And there's going to be things like blood and gore and everything, and what we'll do is we'll replace the blood and gore with something else, or completely disable it whatsoever if you are not comfortable with that. So far, this isn't too bad though. It is temperature degrading. The colors are definitely going to need to be worked on. But overall, it gets the opinion, or gets the thing that I want to work on. Hold on, I forgot to test something at the beginning of this. Oh cool, he's got a helmet on, so that really helps. He's not taking damage. So what's supposed to happen with the heated rocks, if you step on them, they're going to do damage to you and catch you on fire. Once they get the heat map as well, just being nearby will potentially set you on fire as well, because of the fact that it's hot. Oh, wow. He instantly set on fire. Oh, no, the wrong... Okay. Let's take a look at the code real quick. So heated stone is the block we've got. This is something that probably would be nice to have JSON with. Okay, so we don't contain what we're looking for, and it looks like all the colors are not texture based; they're actually based on a value here. So I might come back through here and replace these with a better color scale. I might have to go get somebody like Morton to help me out with that color scale. He'd be the best person to actually ask on that. So I'm going to go ahead and close this, and there actually is a few methods we can add here. So there should be like an on walked on method. On entity walking with block. And then the other method we want is on entity collide. So walking is if you walked on top of it, collide is if you touched it, and we basically want to apply burns to the entity. Right now, how we're going to simulate that until I get a better damage system built, because I actually worked on this a while ago in the Artillex mod. I actually started implementing actual medical stuff in the game. Things like being able to get tetanus from rust, being able to get blood poisoning was actually a big thing. I put blood poisoning in there because you had to use bandages to heal yourself. And if you did not sanitize the bandages, say for example you just washed an old bandage off and reused it, you could get blood poisoning, and the blood poisoning would sit there on your character for hours at end and very, very slowly kill your character. Your character had a chance to immunize to the blood poisoning, so there's a chance that you would survive. But at the same time, there was a chance that the blood poisoning would get more severe, and every time it leveled up, the effects got worse and worse. You would start to get your character start to get tired and sleepy, and would have trouble moving, and you would start dropping tools randomly, and you would have trouble like walking and picking stuff up. You would screw recipes up, you would lose track of items, and eventually your character would croak. Now, unfortunately, because of the way Minecraft is designed, all you have to do is jump into a pot of lava, and then your character dies, and you lose all these effects, which kind of ruins the whole point of it, which is the reason I never actually continued working on it. Anyways, we want to If entity is an instance of entity living, base, entity dot attack, and we want damage source dot, is there fire? Damage source on in fire, because that's what better way to do this. And what we're gonna do is we're just gonna hit him with like 0.5, and then we're gonna go entity dot set fire at 1 tick. Interesting thing is, if you stop moving on this, I think this won't tick on you again, but that's where on entity collide is going to come into play. So on entity collide is going to do the same thing. And we're going to drop the damage on this one, and we're not going to actually set somebody on fire. But if they collide with it, they're going to get set on fire. We'll play around with this. Let's actually set this to like 5. We'll probably do a debug random on the set fire part. We do want to ensure that the person is constantly taking damage. And for those of you going like, why aren't you using whole values for the damage? You got to keep in mind that this, I think, is called 20 times a second. So that would be 20 times that you're applying damage. So this is applying 10 points of damage to the player in that 1 second of time actually colliding with the block. You have to keep in mind that some people have really low reaction times. So that means you collided with a block and instantly died. And yeah, you imagine something like Dire Wolf or people Yogg's cast playing with this, they would be dying almost always from Heated Rocks. Now, Heated Rocks is something I do plan to throw in the nether around lava, so you will see this stuff actually pop up a lot more. And it's going to become more and more dangerous to walk around the nether for some parts. Because one of the things I want to do with the nether is actually make it where you have to run around in certain types of environmental armor down the road to actually not croak. The alternative option is you just take a potion that makes you immune to fire, which is the magical alternative to it, but the technology alternative to it is wearing protective suits. Now the protective suit would be pretty simple. You gotta think, I'm thinking like 50s and 60s era technology when I'm thinking about this. So it would be essentially a vest made out of cotton that would have hoses going through it that would be circulating water. So you would have a backpack with water in it, that would be cool. And it would start ventilating steam because it would be getting heated. And what it would do is it would just keep you cool. And so there'd be a temperature level that would slowly damage you. At least that's one of the things I work on. And this will actually be a slow introduction into space travel as well. Because every single mod that seems to do space travel seems to ignore the fact that there are environmental problems. Galacticraft hit up on it slightly. There are thermal suits now in Galacticraft in some of the newer versions. And whatever Z's mods is called. I forgot the name of it already. I want to say Space Astronomy. That is not the name of the mod, though. That's actually the name of a game I want to buy. His mod is called Space something, I think. Hold on, we can figure this out. I have his mod cloned down because I actually do patches for his mod every so often when I play it. So we'll go to the Armory folder, we'll dart out to 1.7, and it should be somewhere down near their bottom. Sad when I've forgotten the name of it. It's called Advanced Rocketry. Okay, so yeah. So he's got him on Advanced Rocketry. He has said he wants to put thermal stuff in there, and he's been taking a lot of my suggestions on it, but he hasn't hit up on it on the point where I think a mod should focus on. Because one of the big things with making a space travel mod is you should focus more on the experience and less on the technology, and he's spending a lot more time on the technology. So his mod is a little under what I think it could potentially be. And this isn't his fault. He's actually barely got time to work on the mod, and he's noted this several times, and I've laid off of him quite a bit about it. Okay, so these guys aren't taking damage. Oh, damage. Cool. So we're not getting a collide check. So we might want to add a handler for this. Actually, when the heated map comes into play, I won't need a handler for this, because what the heated map will do is it'll go, okay, the spot you're standing at is like 100 Fahrenheit, you're going to start taking damage. Let's go get another nuclear blast going here. Although we have some stuff over here we could probably use. I need to get a villager. Give me a second. Even though I hate to hear the sound of a villager die because it's annoying. Actually, you know what? Slimes work. Slimes have a low HP. Okay, so we'll let this run. Okay, and we have some thermal rocks, so let's go. I'm going to turn fire replacement off at some point here. Okay. Yep, taking damage. It's not a continuous damage though. That's the. Okay, so what we're going to want to do then is we're definitely going to want to set on fire on walking because on collide is not a really big equation runner. So I'm going to guess on collide is something like if you walked into a wall, where this is different. So we're going to want to run that. Okay. Yeah, set on fire there. Okay, yep. Okay, so it's working. And that'll do most of the damage because fire damage is actually quite a lot. The reason why we're still doing normal damage is I want to slightly bypass certain armor types. There are certain armor types that just turn fire damage off altogether. But you're not being hurt by fire damage. You're being hurt by thermal radiation that is being hit on you. So imagine putting a piece of armor on your arm and that piece of armor is getting heated up. It'll eventually cook your skin and it'll hurt a lot. It doesn't have to be a fire source that does that. So if you apply fire, of course, it's going to heat up, but that's not the fire heating it up. That's the thermal energy coming off of the fire that is actually heating it up. So that means there'll be other sources that'll kind of do that. But this will be releasing thermal energy because this rock has stored up a ton of energy. Eventually, by the way, this actual block may disappear from the mod because if I get the heated system going well enough, what you'll see is this block itself change texture or change color, and it'll actually heat up on its own, so I don't have to make new blocks every time I want to reflect that this block is really warm. I can just go into the world render, take over the world render calls, and go, okay, I want you to render slightly brighter or slightly darker, depending on how we want to do it. That being said, in 1.8, that may be a little tricky because I've been told that the render system in 1.8 is a little weird. There isn't exactly the same function calls as there are in 1.7, which is going to be unfortunate. It may mean I may not develop that feature for the newer version of Minecraft, or I may end up just making a ton of extra blocks and doing stuff with. Highly likely I may do some tile entities, although that will be really laggy. It's going to be a bit complicated how I want to do this precisely, because I know there's a lot of drawbacks from doing things a certain way. Tile entity approach, even though a couple mods have used it, and it has proven to not be TPS or FPS intensive, it is bandwidth intensive. So if you're on a network connection, imagine you have 20,000 tiles around you that are all heated up. Even if each tile only sends you 1 byte, that's 20,000 bytes of information that now just got sent to you. And that may not sound like a lot, but you're stacking that on top of the normal game, and it actually can be a significant increase. Most people don't realize this, but about 100 kilobytes is about the limit by which you want to be sending data on a Minecraft client. Anything above that will impair the average user's capability to play the game. The reason I know this is from experimentation of working with one of Reika's mods, where we proved to him scientifically that his mod was causing severe issues because he was sending 1 megabyte of data to the client. He was like, I don't notice any issues running on my server and clients because your server's in your house with you. You can run 10 megabytes of information over your landline before your landline maxes out. But yeah. Anyways, moving on, because we got more we can implement this. One thing we do want to probably do is make rain cool this down really quickly. After all, water's got a huge heat capacity, so there's on rain. I think it's filled with rain. Okay. Currently used by Collagen to increase metadata. Yeah, we can do that. That'll work. I believe this might be a client-side method, though. It's a little hard to figure that out. If world.ran.next float is greater than 0.8, then what we want to do is figure out how we want to do this. Just call update tick. I feel like I want to make this 0.9 because I feel like it's going to take a little bit longer, but we'll test this in a second. The next thing we kind of want to work on, I guess, is... I'm not exactly sure. Because if we just do ores and stuff, we're just kind of cloning the ore blocks. Yeah, let's just do that real quick. So what we're going to do is we're going to make some variations on the ore blocks. So we already have a block for ore, and we already know what ores are going to be registered. So the only thing we really need to do is just make more ore blocks with different textures. We already have a texture system in place to actually make more ore blocks because my texture artist Morton was smart enough to realize that I was going to eventually ask him for more textures. So he went ahead and made me more stuff. So textures, blocks. So I've got in-stone textures in here. I've got netherrack textures in here. So as you can already tell, I've got more textures to work with. I've got stone. Now we need to do cobblestone, sand, gravel, and a few other things. And of course, my dog decides she wants to bug me right this moment. You know what? We're going to go ahead and just do this stuff another day. I apologize for saying I was going to do it and not do it, but my dog wants to go for a walk, and I'm going to be leaving here at 1 anyway, so yeah.